Hey, what's up? It's Jake from Nimbus DevOps, and I want to finish off just talking really quickly about services with ClusterIP and Load Balancer services, and then we'll go ahead and start talking about microservices and what the big fuss is with all that and how it works. So, you've probably noticed before that if you run a kubectl get all or get services, that there's this service cluster IP thing in here. And maybe you even wondered, what the heck is that? So essentially what this is just this particular service is like an internal network that all of the objects inside of a Kubernetes cluster use in order to communicate. So you can think of it like almost like a route table with a router and a switch and and it but I'll try to simplify this. So everything in Kubernetes is an object, right? So a service is an object, and in this case this one is just a default object that comes out of the gate. So let me just show you like an example of how this might work. So let's say that you have a user, okay, and this user wants to oh, use a website. So they would hit some kind of front end, right? And maybe that front end is going to retrieve some information from a database or a backend, right? So essentially, you have a user communicating with a front end, which is communicating with your backend. So in the case that you have, for example, um, some kind of scaling mechanism, this is going to be the most ghetto representation, like this. Maybe you have 5 pods that represent your front end, but you only need 3 backend database pods, right? And you have, a user times, you know, a million users. So in order to relay this traffic efficiently, what you have to do is you need to some sort of uh, representation, like you could think of it like a gateway or a load balancer in front of your front end. And the way that we do that is by creating, um, instead of it coming here, we'll just say that it looks like this. It's going to actually hit a service, and that service is going to represent like a connection to any front end pod. So the user is going to hit the service, and then the service will decide where exactly that traffic is going to go, like which front end pod it's going to go to. Then the front end will need to go to a database, right? Well, we kind of have the same problem. So what we need here is, again, some sort of representation. So what we might have is another service that represents our database. I told you this is like the most ghetto thing ever, if that makes sense. Like this. Isn't that beautiful? Okay, so now let's say that this service here is internal, this service here is internal, because you don't want just anybody being able to get to the database. So if you have an internal service, it's kind of like an internal load balancer. What you want to do is you want to use the cluster IP service. And so this cluster IP will just be a service that will assign, all these pods have IP addresses, and so the service will just forward the request from the front end um, to the appropriate database. So the front end will have a static, either a name, like your service name, like if this is Redis, the front end will just send the request to Redis, right? And then Redis will know, the Redis service will go, okay, I have 3 pods, I'm going to pick this one based on the logic that I'm using. And the same thing holds true here. Like if a user or a bunch of users hit your front end service, they can hit that on um, a single IP address, a static IP address, instead of having to guess which this lives on. If you live on in a multi-node cluster, each of your nodes has a different IP address, so it's possible that, if you have 1,000 nodes, that's a lot, but well, let's say 10. If you have 10 nodes with 1,000 pods on it, that's a lot of potential IP addresses. And so for internal purposes, like we show here, the front end connecting to the database, this is where we'd want to use ClusterIP. And ClusterIP is just a way for the communication to happen inside of your cluster. Now, if you want to go outside the cluster and you want to now set up your Kubernetes cluster in the cloud on something like GCP or AWS or Azure, then you can, instead of using this service as a load balancer, you can use their actual load balancer. So like in AWS, you could use one of their elastic load balancers and then just give it the values of your pods, and it will go ahead and forward that with the rules that you say. Now, because some of these public clouds come pre-configured out of the box with Kubernetes, so you can just tell it that it's a load balancer. And if you're on AWS, it's going to know to go look for or create a load balancer for your Kubernetes cluster, which is super nice. If you were to do this like on a Raspberry Pi or something like that, you basically have to set up like a HA proxy or something like that to do the equivalent. So that's really the difference. Think load balancer is for public cloud and ClusterIP is for internal, and then your node port that we already went over would be like the external access. So in this scenario here, if this was on my computer like it is right now, I would use node port for this service and I would use ClusterIP for this service. If this was in the cloud, I might use the load balancer for this service, and then I would use ClusterIP here. So that's just kind of like a high level difference between the two. So I'm going to go ahead and stop this video and then go straight into making another one that is going to start building out a multi-tier application from the Docker examples repository on GitHub that I learned from codecloud.com, which is an amazing resource and I recommend for learning anything about Kubernetes. So that's really, at this point, I will get into networking later in a deep dive, but this is not a deep dive. This is just a high-level overview of ClusterIP and load balancer. Let me know if you have any questions, and see you in the next one.